So today we're going to talk about adding vectors graphically. Let's say we have two vectors. Vector 1, a 15 Newton vector, opening up at 20 degrees in this direction. We'll make that the red vector. And then we'll say we have vector 2, which is a blue vector, 12 newtons, opening up at 60 degrees. It's important to note which direction these are opening up from, because although the one is 20 degrees and the other one's 60, they're being measured from different axes. So we have to be careful with that. So the next thing we need to do is draw two lines crossing each other as a coordinate system for our force diagram, or so for our vectors that we're going to draw. The next thing I need to do is figure out how to make the angle 20 degrees. So I bring my protractor over, take the crosshairs, and put them at the origin that I just created. So the crosshairs are the point where the 90-degree line meets the 0-degree line. Now I'm going to look to the left and count up to 20 degrees. Once I get to 20 degrees, I'm going to make a little dot. That dot represents a line that would make 20 degrees. So if I draw a line from that dot to the origin, the line would be at 20 degrees. So now I'm ready to draw my vector. But I need to figure out how long the vector is going to be. So how do I translate 15 newtons into some sort of length? So I'm going to decide that my scale, so I can put newtons onto paper, I'm going to let 3 newtons equal 1 centimeter. So 3 newtons in real life will equal 1 centimeter on my paper. So if I look and take my 15 Newton force, my force 1, I can convert it as though I was doing a unit conversion problem. So I'll take 15 newtons. I know that I want to get rid of the newtons, so I'll divide by 3 newtons. And then I know 3 newtons is the same thing as 1 centimeter. So this is 1, the newtons will divide, and I'll be left with a force vector that's 5 centimeters long on paper. I can do the same thing with my 12 Newton force. So 12 newtons, I'm going to divide by 3 newtons, because 3 newtons is equal to 1 centimeter. Newtons are going to divide, and I'll be left with a 4 centimeter vector. So that's the length of vector 2. Now I can go back and take a look at drawing my actual vector. I'll take the straight edge of my protractor or ruler, line it up between the 2 points that I made earlier. So this line that I'm about to draw will be at 20 degrees. And then I'm going to draw a vector arrow from the origin out to 5 centimeters. Because my vector is 5 centimeters. So my 15 Newton vector is going to be represented by 5 centimeters on this paper at 20 degrees. I'll move my ruler out of the way. It's important to remember that when we add vectors, we place the tail of our second vector on the tip of our first vector. So we go tip to tail. So I'm going to start drawing this vector by marking the angle from the tip of my first vector. So I'll go up to 60 degrees and make a little mark. So I made my mark. Now I can connect the ruler to the point that I've made and the tip of my other vector and draw my second vector. I'm going to make this 4 centimeters long. The 12 Newton vector is represented by 4 centimeters. Finally, we'll draw the resultant vector from the tail of our original vector to the tip of our last vector. The purple one here represents our resultant vector. I'm going to measure to see how long our resultant vector is, and it looks to me to be about 5.8 centimeters. I know 3 newtons equals 1 centimeter, so if this is a 5.8 centimeter vector on paper, I need to figure out how many newtons that represents. Like I said, I know 1 centimeter equals 3 newtons, so I set the centimeters on the denominator because I want the centimeters to divide. I multiply 5.8 times 3 newtons and we get 17.4 newtons. So now I know the length of my vector is 17.4 newtons. I'll go back up top, write down my 17.4 newtons in the length of the resultant. Now to figure out the angle, I'm going to count up and find that we go to about 63 degrees. Now it's important to make this little symbol, because 63 degrees could be opening up from anywhere. So I'm letting you know that we're opening up from the horizontal axis on the left. Let's look at this next problem. So I think I'm going to call this first one force 1, I'll call the second one force 2. Force 2 we notice is opening 60 degrees up from the horizontal axis. It's a force of 12 newtons. Force 1 is opening 30 degrees up from the x-axis, from the y-axis. Notice this is a little bit different, and it's a 10 Newton force. So just like we started the last problem, I need to have some sort of coordinate system. So next, like we did before, I'm going to start from my origin. So I'm going to line up my protractor because I have to draw this first force from the origin. But the problem here is that I can't draw a force down here in the fourth quadrant without these numbers. So what I'm going to do is I'm going to rotate my protractor 90 degrees. So because I'm measuring the force from negative y-axis down here, I want to line up the edge of my edge of my protractor with that axis. So now I'm going to count up 30 degrees. I made my mark. And now I need to figure out how long this force is going to be. So if I go down to my calculations section, I think now I'm going to choose to have a scale of 4 newtons equaling 1 centimeter. Force 1, I know that that's a 10 Newton force. So just like I'm doing my FLM or unit conversions or dimensional analysis, I want newtons on the bottom. I'm trying to get to centimeters. I happen to know there are 4 newtons in 1 centimeter because that's the conversion vector that I chose. The newtons will divide, and I'll be left with 2.5 centimeters. So that's going to be how long my first force is. So I do the same thing for force 2. This is a 12 Newton force. But just like above, I know I want to get newtons in the bottom to divide with the newtons in the top. I have 4 newtons is equal to 1 centimeter. So those newtons will divide, and I'm going to be left with 3 centimeters. So going back up to the top, now I can get my ruler out here and draw a force that's going to be 2.5 centimeters long. I'm going to draw my next vector starting from the tip of the vector that I just drew. I'm going to bring my protractor back over, but now notice that we're measuring this vector from the horizontal. So I'm going to have to turn my protractor back. We're measuring a 60-degree angle. So it's opening up from this horizontal axis. I'm going to count from that side up until I get to 60 degrees. Made my mark. Get my protractor out of here. Bring my ruler back down. I'm going to want a force vector that this time has to be 3 centimeters long. Now I have to draw the last vector. So that vector is going to be from where I started to the very tip. We can extend this out to just check and see what kind of angle we have here. So it looks to me like it's about 7 degrees, maybe a little bit more than 7 degrees. Now it's important that we, again, write down that this is opening up in this direction. So that's what the angle looks like. So now let's see, what kind of magnitude do we have here? That force looks to be about 2.8. We'll say 2.8 centimeters. So if that vector is 2.8 centimeters, now we're just doing the reverse order from what we were doing before. Instead of putting the newtons in the bottom, I think I'm going to put the centimeters in the denominator because I want the centimeters to divide. And then I'll put the newtons on the top. So the centimeters will divide, and I'll be left with a force of 11.2 newtons. So this resultant vector is an 11.2 Newton force at an angle of 7 degrees, opening up in this direction.